On some of the transformations of the sine function. We've graphed so far just the parent of it. Here are some important things for you to know. If I give you an equation that looks like this, the A helps you with the amplitude. It's always the absolute value. So absolute value, that number in front of the sine function, the multiplier, is your amplitude. It's always absolute value. You can't have a negative amplitude. To find the period, how long a revolution occurs, we have to look at this little b here. And we say, take 2 pi and divide it by b. The next thing is plus d. If you have a plus or minus, what that does is it shifts it up or down. So if you have a plus d, it moves it up. If you have a minus d, it's going to translate it down that many units. There are some reflections too when you have a negative a. And we'll talk about how that looks later. We do also have some transformations left and right, but I want to save that for another day. And again, remember, here are some of your features for your sine function. Your period is 2 pi, amplitude, domain, and range. All right, so what we're going to do now is apply some of those equation pieces and do some transformations. So one of the things we notice is there's a number 3 here. That's your A. So your amplitude is going to be the absolute value of 3, which is 3. Your B value is 2. So how you find your period is 2 pi over b. So since our b is 2, we plug that in. 2 pi over 2, we reduce that fraction, and we get pi. So the length of one revolution is pi. The parent function, remember, was 2 pi. So it takes half the amount of time for you to do one revolution. So amplitude is 3, 1, 2, 3 up, and 1, 2, 3 down. And now one revolution is pi. So now what I do is I just split up into 4 equal parts again. Halfway would be pi over 2. Halfway again from 0 to pi over 2 is a quarter. Halfway between pi over 2 and pi is 3 pi over 4. We're going to expect that you know your fractions in these examples. Now, with the sine function, I say it starts in the middle. It goes up to the top of the amplitude. It goes to the middle again. It goes to the bottom of the amplitude. And then back to the axes. So how this looks with one revolution is like that. Now, if you wanted to continue another revolution, which we'll do, just add another period. So now my second revolution will be 2 pi. So I add a pi on, and I split up in half. Halfway between pi and 2 pi is 3 pi over 2, and I split up in fourths. So if you want to count it, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and then continue on. So I'm going to just change the color here. So I will continue going up to the middle, to the bottom of the amplitude, to the middle. And there would be a second revolution. This is one revolution. This would be a second revolution. All right, let's graph this one. So here is my A, and my A is a -1. My amplitude is the opposite, or the absolute value of A, which is 1. My B value is 1. So to find my period, it's 2 pi over B, 2 pi over 1 is 2 pi. So it's the same as its parent function. But there is a negative in front of that sine function. So what it's going to do is going to reflect it. So normally, our order pairs would kind of go up, and what we're going to do is we're going to go the opposite way. We're going to go down. So I'll show you that with our graph. All right, so amplitude is 1. So here's our 0, our positive 1, and our negative 1. Period is 2 pi. So start at 0, ended at 2 pi, split into 4 equal parts. So halfway would be pi. Halfway again would be pi over 2. Halfway again would be 3 pi over 2. Now this is the sine function. We start in the middle, and normally we would go up to the top of the amplitude, but we're going to go in the opposite way. We're going to go to the bottom of the amplitude. So here's our first point, to the middle. There's our second point, to the top of the amplitude. There's our third point, and back to the middle. There is 1 revolution. If you want to continue another revolution, add another 2 pi, split up into 4 equal parts, and continue with your dots. What if you give you something like this? This looks a little bit confusing. Here is a plus 3. What I want you to do is I want you to rewrite it as the sine of x plus 3. And what this plus 3 is telling me is to move the entire graph up 3 units. So here's how it would look. Here's my traditional x-axis. I'm going to just push it up 3 units. So 1, 2, 3. I'm going to graph this imaginary horizontal axis. And then I'm going to go up 1 and down 1. Now my period and amplitude haven't changed at all from its parent. So here's 2 pi, here's 0, halfway, halfway again. So you split up in 4 equal parts. Now we graph the sine. The sine starts in the middle, but remember our horizontal axis has now been shifted up 3 units. So it's on that purple one. So now we go to the top of the amplitude, to the middle, which is your horizontal axis, now shifted up, to the bottom, back to the middle. So there would be 1 revolution.